Hey guys, so today we're going to talk about density. We're going to specify about what is density. On my previous video, we did density and we tested out items, whether they sink or float. Today I'm going to go a little bit more in depth and I'm going to explain what does it mean to be more dense or less dense. All right, so let's get to it. So density usually you can sort things out in two ways, either more dense or less dense. Okay? So that's basically how you can sort things out. More dense or less dense. If it has more density, okay, that means it has more mass per volume. Okay? I'll give you an example. Okay. I have a styrofoam ball here and I have a lead ball, which is about the same size. Okay? Now, which one do you predict has more density? The lead ball or the styrofoam ball? Okay? So in order to find that out, you need to think about what is density, okay? So the more mass an object has, so for example, if the mass of an object is a lot, like this lead ball, okay? We're going to say that it is more dense. So the molecules inside the ball are very packed together. And because they're very packed together, that means it has more mass. Each molecule has more mass than its counterpart, the styrofoam. This is going to be the lead ball. Okay? And I can feel how much more mass this has. So if I was to put this in water, I would definitely know this will sink. Okay? Now, on the other hand, we have the styrofoam ball. The styrofoam ball doesn't have a lot of mass, and it has the same volume as the lead ball. As the lead ball, it has the same volume. The only thing that's changing is the mass, and because the styrofoam ball has less mass, its molecules are a little bit more spread out. There's more space in between. Okay? And because there's more space, that means it will float. Okay? It will float on top of water. Okay? So that's basically what we're testing today. Okay? We're going to get a little bit more information when I do the experiment. Okay, so what we're gonna do today in today's experiment, we're gonna test that out, whether because it has more space, is it gonna make it float, or because it has more stuff inside, which is the mass, is it going to sink? Okay, so those are my two things that I'm thinking about. What's gonna happen? Okay, so I'm gonna use, of course, water, because that's where I'm testing it. I'm testing it for relative density. Is it going to sink or float? And then I have four different things that I'm going to test. The first thing is I'm going to test a container that has nothing but air. Okay, so what do you guys predict is going to happen when I dump it in the water? All right. Next, I added 15 milliliters of sand. So as you can see, it's partially full. It has about 1/3% in there. Okay. And then I'm going to test out 2/3 or 30 milliliters of sand in there. And as you can see, there's still some space. Okay. Would that be enough sand to make it sink? Okay. Again, we were talking about compared to how much stuff versus how much space. Okay. And that's what's going to give you the density. The more stuff per space, the more denser it becomes. The more molecules, the more denser it becomes. All right, and finally, we're gonna get one that's kind of full, almost all the way up. And because it's full, it doesn't have really much air in there. And as you can see, it barely has a little bit, okay? So those are the four containers that we're gonna test in the water. And we're gonna see which one, if my prediction is correct, the more molecules inside the container, or the more molecules inside an object, is it going to sink more, or is it going to have more density? Okay, and again, we have to maintain something the same. So in this case, we're using the same container for all the trials that we're going to do. Okay, all right, let's get to it. All right, so right here I have the water that I'm gonna test it on. And the first one that I'm gonna use is the empty container. What do you guys think is going to happen? Okay, as you can see, if I push it down, it still floats, okay? So the reason why it floats is because the amount of volume versus the amount of space of mass that it's taking up, okay, is much bigger. The volume is much bigger, so it's a lot more space. Therefore, it floats. Let's close the gap a little bit. We're gonna add a little bit of sand, and let's see. Do you think this is gonna float, or do you think there's still a lot of space in between? Let's test it out. Okay, and as you can see, it still floats. It doesn't want to go to the bottom yet. I push it down and it comes back up. So that means that this right here floats and still not enough mass to overcome the volume. Okay, the next step is the third one, which is gonna be 2/3 of sand. Okay, let's see. Do you guys think this one's gonna sink? Most of it is filled up. We have a little bit of air. Okay. And it does go down. Notice that it is touching the floor, okay? And because it is touching the floor, that means it is sinking. So because it sinks, that means that it has more mass, more molecules in there, more mass versus the amount of space. So if I was to replicate this, if I was to double the size of the container, I would just have to double the size of sand, the amount of sand that I'm gonna put, and it will still sink because it's gonna keep the same ratio, okay? And finally, because we know the other one sank, we know that this one, of course, because it has more molecules, I'm going to assume this one has to sink, okay? It has to sink. Why? Because my previous model, it sank. So, let's test it out. And it definitely goes all the way to the bottom, okay? So it does sink. All right. So what have we learned here? We learned that mass definitely has an effect on the density. And then, of course, the volume, you have to compare that with the mass. So the more molecules that are packed inside an object with a smaller amount of volume, then, of course, the more dense it becomes. The less molecules in there with more space, the less dense it becomes. So it would float, okay? So what are some examples that you guys think will float? Okay, we said the styrofoam will float. And yes, it would float. The metal ball, mostly, almost every metal will float, unless you turn it into like a boat or something. But that's something else. That would be considered buoyancy, which we can talk about some other time. All right, guys. So I hope this video helps you guys. Remember, the more dense, that means that the more molecules are stuffed inside, more compact together. Okay. The less dense, the more space there is and a little bit of molecules, okay? So another example would be wood would float, Plastic could float depending on how compressed the plastic is. Plastic bottles, I know those float. Even if you fill them up with water, they still float. Okay. Tennis ball, ping pong balls, all of those will float. Metals will sink. What else? Rubber most likely will sink. Okay. So think about those things when you're walking around and about in the nature. Throw a rock into the pond. Will it sink? Will it float? Throw something else. Throw a small stick. Will it sink? Will it float? Okay. So those are small things that you should be doing at home that you need to always keep in mind. Does it sink? Does it float? Why? Why not? Okay. Also, when your mom's cooking and she puts oil on water or water and oil, what's gonna happen? Okay. Is it gonna sink? Is it gonna float? Okay. Simple things like that. Always be on the lookout to test them out. Okay. Be careful. Be safe. See you guys next time. Thank you for watching. This is Mr. Santos, Science Lab.